Hi, welcome to the AI21 Labs Lab AI Hackathon. Not the official name, obviously. And Hi, I'm Yuval. I'm developer advocate at AI21 Labs. I'm really happy to be here. Really super stoked and excited about this hackathon and what we're going to do here. And essentially, right, what everything we will do here is that in the upcoming week, you will use our models in order to build applications or build some sort of a project which is text-based related. And myself and Yotam, which you will meet tomorrow, both of us are developer advocates. And something that we both of us really like is the show called Rick and Morty. I hope that you know it, but if not, let me introduce you to several seconds from it to really get you into the zone.
Yuval, is there supposed to be any audio with this video?
Yes, you can't hear it?
Nope, we're not getting the audio, but it is a nice video.
I will post a link to this video later so you can see it. I can hear the audio, and it's funny even like the 10th time that I've seen it. So
We will definitely check it out. For now, can you just tell us
Yeah,
essentially
okay, so
what was not written?
Yeah, okay, so it's finished. Essentially what you're seeing here, those are the main characters. Rick is the grandfather, Morty is the grandson, and Summer is also Morty's sister. And what you see here is they're playing with some sort of a text-based adventure games, which in case you're living under a rock and you're not familiar with it, they're referencing to AI Dungeon. If you like D&D, but online, I really recommend to check it out. And like as a side note, fun fact, our language models, AI21 Studios language models, are the one who's powering this. So both Yotam and myself thought, what we want to do is to build something for this hackathon, like do a project in order to get to see all the process and to really convey it in a comfortable way. And we thought to ourselves, well, I wish we had more episodes of Rick and Morty, right? There's like 10 episodes per season, only 6 seasons. So we thought, why not use our language models in order to generate more episodes? So let's take a look at the app. Okay, so we have an app. It is in the GitHub. Yotam will also go with you again tomorrow about all the the way of the building, considering the front end and the JavaScript. But here you can see we can just generate a title for an episode. So for instance, Fun Boy Must Die, and then generate a summary plot for the episode. You can see here something. And every Rick and Morty episode ends with a post-credits scene, so we can generate that as well based on what we've been here before. Okay, so this project is something which is open source. You can check it out afterwards. But what I want to focus on is how we did that, how we did the engine behind that, how we managed to take AI21 Labs models and build something with it. And I will walk you through it in this workshop. We have like 40 minutes where we'll see how did we do it, and hopefully you will understand how to start build your own project. So whatever you've seen there, right? You've seen that I pressed a button and some text was generated. And this was generated using our calling to our large language model. So let's just really take a few minutes to really understand in a high level what is a large model and why it's so special. So you can think about it as an algorithm, okay, like a model that receives plain text, okay, all the communication is in English. So for instance, the input to this model will be language models can predict the next, and the output will be word, okay, which essentially, this is what it is. Given a sequence of text, get some sort of input text. The model essentially predicts the next word that is the most probable given this text. Okay, so it's not just a word. So what happens, we will take this word, concatenate it to the input, and continue on and on and on again until we will get text. Okay, this is essentially really what you've seen there. The model just generates more and more text. And the thing that is very, very special about large language models, which is really in the last couple of years, is that you don't really need one model for every assignment, every task. You can use one model to rule everything, to do everything you want. And it is all about the fact that whatever text you put into the model to get the text out. Okay, so like we said before, language models, given a sequence of text, they essentially predict the next word and word and word and word. You can think about it really as like a smart autocompletion, where if you put the correct text in the input, they will catch up and do whatever we want. So you can use this model to do classify, for instance. You just tell it in the input, classify the following paragraph, blah, 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 and it will tell you this is sports. You can use it to do rewrite, right? So let's say you enter this quote, you miss 100% of the shots you don't take by Wayne Gretzky, and then the model outputs the shots you don't take are missed 100% of the time. And Jurassic 1, so Jurassic 1 is the series of our large language models. We will cover them shortly. This is what happens from our language models in AI21 Studio. You can ask it to summarize. You can just enter some sort of a test and say, summarize the following text. And here you will get a short summary. You can ask it to generate. Okay, so this was very in hype a month ago when the World Cup was airing. Right, you needed a lot of content, so you can just write a sarcastic tweet about the World Cup and get something which is very sarcastic, very Twitter-based, and really, it really can do whatever you want as long as it's text-based and as long as you're putting the correct input text in order to get what you want in the output. So let's just talk in like the professional notations. So we call the input a prompt. Okay, and I'm guessing this word is very, very popular now, both with the generative AI for the image generation. Okay, so a prompt is the input for the model, and the completion is what the model outputs. Okay, like we said, you can think about it as a smart auto-completion. So we want to build our model, and again, throughout this workshop, what we will do is essentially we will go through the process of building the app that you just seen. So like we said, if the language models can do whatever we want, we can also make it be a Rick and Morty episode generator. So we settle on the concept. We said, hey, let's build this. Great. This was the step number 1. Step number 2 is choosing the settings, which essentially the 2 important parts here is to figure out which model we want to use and which kind of prompt do we want to use. Okay, and this is something that will not just remain the same from step 2 all the way. You can just start and you have to test several things. But let's discuss now how prompts look like and what are the available models that we have. So first of all, what you see here, this is a screenshot from our playground, which we'll play with it shortly. This is a no-code environment to interact with our language models, which you can later get to a code. Okay, so you can see here, our prompt is generate a new made-up Rick and Morty episode title. Okay, this is the prompt. This is what we are entering the model, and we call it a zero-shot prompt because it doesn't have any example. Okay, 0. We just give it an instruction and see what happens. And now we need to distinguish between several types of language models. So the language models, the most naive, and you may say, are what you call the vanilla language models, and they will just tend to continue the text. Okay, so you can see here Morty the clown, but then generate a new made-up episode, Rick the milkman, and another one. Okay, in bold you can see the completion that the model provided. So here you can see the interesting thing that we already talked about, right? patterns. The model is very tend to complete patterns, and what we want to do is to take this to our advantage. Okay, and why is this happening in the vanilla language models? Where essentially those models trained on the entire internet, on very, very large data set, and their mission was same as always, just given a piece of text, predict the next word. Okay, so they haven't seen a lot of instructions in those texts. So they do tend to work with patterns. Okay, it doesn't make them weaker or less good than instructions. It just means that we need to work with them in another way. But which kind of models can we use those kind of prompts? So an instruct model, okay, where you can see here, we entered generate a new made up Rick and Morty episode title, and it just gives us something in bold, and it finishes, right? It followed the instruction. Okay, these are language models that are fine-tuned a bit to really be aligned to following instruction. Doesn't necessarily make them better. And if we want to work with our vanilla models, which are also very powerful models, what it's better to do is to use something which is called a few-shot prompt. Okay, so if you remember before we had a zero-shot prompt, meaning 0 examples. Now in the few-shot prompt, what we want to do is to provide the model several examples, several pairs of input-output or prompt completion that we will be very happy with. So you can see here in pink, okay, you can see our 3 examples. Generate a new made-up Morty title, aquarium full of mortfish, and so on and so on. You can see that all of them are separated between a sequence that is very easy to see, right? I think it's very clear to see those 2 hashes. And this prompt ends with the green, just an instruction. Okay, so all of this is the prompt. This is something which goes inside the model. Now, what are the models that are available for you for those kind of prompts? So we have the vanilla models that requires few-shot, which comes in 3 sizes. All of these are in the Jurassic 1 family. So you have Jurassic 1 or J1 for short, J1 large, J1 grande, and J1 jumbo. And if you want to use it for instructions, you can use J1 instruct, which is based on grande, but has been fine-tuned for that mission. Okay, and we'll see what happens, and we'll play a little with the playground for that. Okay. Now, after we notice, okay, this is what the options that we have those kind of prompts and those kind of models. What we need to do is to collect examples. Okay, and either because we understand that if we don't want just ideations, if we want the model to be really work like the way we want it to, so instruct would probably be much more free. Okay, instruct would probably just surprise us sometimes, where if we will collect examples and show several examples to the model, what will happen is that the model will be much more aligned to our use case. So in this case, what I did, just scraped Wikipedia and just took all the summaries and the episode titles of the actual Rick and Morty in order to be based on that, because I wanted to capture the spirit of the actual scripts. And step number 4 is the prompt engineering. And really step 3 and step 4 are really kind of together. And in order for us to do the prompt engineering part, I want to take you to the playground, the AI21 Studio playground, and then we could explain more and understand. So this is our playground. This is a no-code environment to interact with our large language models. So over here you can see you can choose between J1 large, grande, instruct, and jumbo. And if you have some sort of trained custom models, you can also see them here, but we will get to it soon. You can see here several parameters that we will cover shortly. And here you can just write a text, and by pressing generate, we will get the completion. So for instance, let's try our model. Here is a title for a new Rick and Morty episode. So I finished entering the prompt, I'm hitting generate, and let's see what happens. Rick and Morty get trapped in a video game. No, seriously, they should do that. No, seriously, they should do that. Okay, this is nice. This is fun, but this is maybe not the optimal prompt. Okay, it's called prompt engineering. It's really, reminds like an art form, and there's a lot of trial and error here throughout this process. So, for instance, instead of say here is a title, you can say you can ask the model suggest a title for a new Rick and Morty episode, Rick and Morty versus the Smith. Okay, and maybe you can say suggest witty and funny, right? Add some adjectives or something like that for Rick and Morty episode. Rick and Morty rejected by every girl. Okay, and you can say this is nice, this is fun. It may be enough for your use case, but let's see the other option. Let's see how to do it using using some sort of examples, using few shot prompt. Okay, so here I have the Wikipedia page of Rick and Morty open, and okay, there are here like for every season. Let's for instance look at season 1, and you see here the titles, plots, and so on, the post-credit scenes. So you can collect from that if you really want to capture this type of thing. What we did is actually just we used instruct a little and our imagination in order to build a few shot prompt. Okay, so I already have it over here, so I will just prepare it in advance, and you can see here this is the prompt that we actually chose to do at the end. So generate a new made-up prompt for Rick and Morty episode title. So you can see here we have 4 examples with my favorite Morty Crest superstar. Okay, and you can see we have 1, 2, 3, 4 examples. And let's see what happens when we generate. So now we're working on J1 Grande instead of J1 Grande instruct. So let's see what we get here. Morty's first band. Okay, and really what you really want to do is to try several phrasing, several models. Maybe with Jumbo this will work a bit different. Okay, and maybe one generation is not enough. You can always, if you want to share with your friend or people, like, okay, I'm working on this prompt. Instead of just copy paste, you can press here the share preset, and this will take you directly. Okay, so let's see what happens here. It takes me directly to the prompt and the same settings that we had here of the model. Okay, and what you can also save it. Let's say test preset. And if I'm saving it now, you can see it over here on the side, and I can just go between several presets here, which are essentially few shot prompts that we showed you an example. For instance, you can, when you're looking for ideations, you can come here and see, well, I have here a long form online creator. Let's see what happens. Okay, or like an instruction to SQL. Really a lot of models here, and you can see I can return to my test preset because I already saved it. Okay, after I'm finishing with my prompt engineering, I can just press on the code here, and it will import me for either Python, JavaScript, or curl, and I can just take that and run with it. Up until now, all I did was just to talk about the actual prompt and not the parameters. So let's talk about them a little and try to understand how to leverage them. Okay, because it's not enough only to control about the text. There are several parameters we can harness to our advantage. So the main type of parameters which are relevant for you are generation parameters, meaning when will the model stop generate, and sampling parameters, and most importantly is the temperature. So when generation parameters, this is where we ask ourselves the question, when does a large language model stop generating? And there are 3 options. The first option is the model recognizes that it's done. So it's essentially just stop generating by itself. Okay, and this is something we've already seen, that generate a new made-up. You see, it just understood that it's finished, stopped, nothing special. Okay, this is something which you will see happens in instruct models a lot, but If you want to make vanilla models to stop, what you need to do is to use the stop sequence. Okay, so we've seen this prompt several slides before, where we provide several examples to our model. And here again, all these examples, it works because we leverage the fact that the model can latch into patterns and it will just follow the pattern. So you can see, because we provided 3 examples in our prompt, that between every example we separated with this 2 hashes, what will happen is that the model will generate whatever it needs to generate and will generate this sequence also. So what we want to do is to set a stop sequence in this case. So after the model will generate the stop sequence, we know that it's finished. Okay, and we don't need to continue anymore. The third option to when a model will stop generating is a much more artificial way, and this is a parameter called max tokens. And essentially, if a limit of max tokens has been reached, the thing that will happen is that the model will just stop generating. It will halt generate, but it will look very disruptive. It doesn't. It's essentially cut off. No real logic here. And like a common mistake that people do when they think about max tokens is that they think that if they will set it to a high value, it will actually make a difference. So I do want to say the value of max tokens does not encourage the model to generate more and more and more text. Okay, and oh, I'm sorry, I forgot to say that. Okay, so we talk about max tokens here. Up until now, we talked about the fact that large language models work at generating a word. So they really do work in something which is called a tokens, and not in words. But you can really think about every token as a word. Okay, it's not that different. So if you will set up max tokens to be large, it will not result in a higher, in a longer generation. Okay, the only thing that it does, it cuts off the model if it reached this value. But it doesn't mean that your generation will be longer. What do I mean? So let's go back here to our playground, and you see now we're working with a few shot prompts. Let's say that the maximum completion length, this is the max token, and let's give it 2 tokens, right? And let's see what happens. So the rig, and it's just stopped. Okay, you've seen it haven't given me a full completion. Now let's change it to 10 tokens and see what happens. So the rig principle, and now we get here the stop sequence, which is set over here. Okay, we just insert it and press tab, and you can see that the stop sequence is working. And let's say that I'm taking the max completion to 200. So the thing that happens is essentially nothing. Okay, so it doesn't matter in this case if it's like 10 or 20 or 200. What you really want to do is to set the max token parameter into some value that will not disturb, right? You just want it to, okay, if it's way too long, then I want it to be cut out. But if not, right, it doesn't matter, 200 or 300. If you're expecting completions in like 20, 30 words, it really shouldn't matter. Okay, so this is about that. The stop sequence is over here, and you can have multiple stop sequence, right? You can really have as much as you want. It doesn't matter. It supports a lot of them. And the maximum completion length over here is the max token. So these were the generation parameters. Let's go to talk about the sampling parameters, which is the temperature. Okay, and you may have seen that when I generated the text, sometimes the model just returned the same completion again and again, and sometimes it's not. It made totally different completions. And here is where temperature really comes to our aid. And you can think about temperature as like a number that controls the trade-off between accuracy and creativity. Okay, so why are the smileys here? So temperature is clearly it can be cold and it can be warm. So we say a cold temperature or low temperature is high accuracy, and high temperature is high creativity. Let's see what I mean by that. So let's just assume for a second a very simplistic example that the prompt that we are inserting is I will. and we don't, right? We just put it in the model and want to see what it will turn out. And let's say that we run it several times. So if my temperature will be low, namely even temperature 0, what will happen is that the model will have a tendency to be accurate, meaning always want to return the thing that it thinks it's the most probable. So essentially it will say, I will survive, and then you will run it again. Again, it will say, I will survive, and again, and again, and again. Whereas if you will set the temperature high, what will happen is that the model will be much more free. It will say, okay, there are several things that are probable. I will just return something else every time. So in our simplistic case, it will return survive one time, but then maybe it can return always love you, or I will wait for you. So what is with the temperature? Okay, so we really need to think about the task. Okay, and if your task requires high accuracy, such as text classification or extraction, or essentially every time where you need your output, the completion, to be rather short and very accurate, not about creativity, not about something like that, use low temperature. If you want to do generative labeling, content generation, or longer text, you can crank up the temperature. Okay, and we really recommend to work with like temperature 0.7 most of the time, and like, just play it from there. And let's just see an example here. So you can see that in this case, I will putting my temperature to be 0 in our prompt, and now it's Ricks and Morty's. I'm doing clear completion and I'm generating again Rick and Morty's, Ricks and Morty's. Okay, we got the same completion over and over again. Whereas will I take the temperature to be a bit higher? So you can see total recall. Let's see another example. Okay, Rick and Morty get to the acid. So here, sorry, this is where temperature really comes in handy. The last step in the building, it is optional. It's another service we provide. You don't have to do it in this hackathon. Only do it if you feel that you need to. And this is to train a custom model. And the advantages of this are, there are three main, which is, the first is it's tailored to your specific data. Essentially, the model keeps training on the data that you will feed it, so it will be much more biased to work with your kind of data. It is something that has faster performance and lower latency because you don't need few shot you don't need few shot prompts in order to work with that. And it has adversarial robustness, which I will just say a word, and if it confuses you, you can just forget all about it. But maybe you've seen in the last couple of months, a lot of people try to hack all those kind of language models, where essentially you want them to get what is the prompt or something like that. So when you do a custom model, it's much more robust to those kind of things. So how do we do that? What you need to do is to build a dataset which contains at least 50 examples. Then you need to train it on one of our vanilla models and use zero-shot prompts to query that. Okay, so now that we've talked about all of this, let's code. Let's see how all this happens in code. Sorry, where we will essentially see it through a Python notebook, okay, which is in the GitHub. You can find it, you can play with it yourself. And let's see what happens here. Okay, and really this is the perfect example of all the things you can do given a dataset. Okay, so first of all, we have some installations here. Okay, pandas, numpy, JSON, and AI21. This is our Python SDK. Then what we need to do is to fill the API key, okay, which you can use it in, you can take it from your page in AI21 Studio. As you can see, I already ran my API key over here, so we can continue from here. I will say, okay, your API key is connected to your account, and this is the way we build, this is the way the credits are reducing. So don't share your API key with anybody other than your teammates, okay? Because once someone have your API key, they can just use it to query models. So let's see the Rick and Morty dataset that I've built. Okay, essentially scraping of Wikipedia. Okay, so we're loading it. Again, this file is in the GitHub, and this is how it looks like. We have season, the episode number, the title, the summary, and the post-credits summary. I hope that now you can see better. There are several parameters here. So the separator is essentially will be the stop sequence, the subset size and the seed are those are the parameters that I need in order to work with the few shot. Okay, essentially what I want to do is to use the actual summaries and the titles of the Rick and Morty episodes as the examples in the few shot. Okay, and because the prompt is something which is limited roughly to 2,000 words, I cannot use all the 60 episodes. So I will just random some sort of subsample. Okay, and here it's enough. And let's see what happens here. Okay, so what we want to do is first to build a title generator. Okay, so we have three different models here that we use, three different prompts that we use to call them. And the first will be, let's just create a title. And here we need nothing, right? We don't need anything from the user to actually input. So it will look something like this. Generate a new made-up Rick and Morty episode title, and so on and so on. And these are all actual episode titles. Now it's time to generate. Okay, so you can see here I'm using the Python SDK, but you can also use it with any other language just through HTTP request. And you can see here I'm choosing the model to be J1 Grande. I'm entering the prompt. Max tokens is 20 because I'm not expecting it to be very, very long. Stop sequence the separator, and the temperature is 0.7. All of those are things that I optimized using the playground. Through the playground, I understand what is the value of max tokens and which temperature I want to use. Now let's see what happens. The Recurrian morphed it. Okay, and this is a very good example of a case where large language models may disappoint us, and we need to figure it out. So this is an actual name of an actual episode. Okay, and why does it happen? So essentially, the model trained on all the internet, so it knows the real names of the episodes. So in this case, because we provided several real episodes, and these are all short, the model is very biased to give us those kind of things because they are very probable. So in this case, what we did is just add some made-up titles, like you've seen in the prompt that I showed you before. And now this is how my product will look like, and you can see there are several examples, but instead of using the actual titles, I'm using the made-up titles. Okay, and now let's see what happens. Again, the same API call. Rick needs a hug. Much better, and this is not an actual. This is not an actual name. So let's continue. Now we want to do the episode generator. Okay, and here we want the episode generator we want the query to be for a title, right? We want to provide a title and then to get a summary of an episode. So this is what we will have here. Create prompt for summary, given a title, it looks something like this. Make single example. So it will give us the input output, the prompt completion pairs from that the few shot will be comprised. And this is the function that essentially says, if I want to create a prompt, just take the prefix of the input output examples, add a separator, stop sequence, and create summary for the new one. And let's see how it looks like for the generated title that we had before. Okay, so generate a Rick and Morty episode based on the title, episode, stop sequence, and so on and so on. All of the examples are from the dataset from real examples. And here we have, for this title, Rick needs a hug. And now, again, what we want to do is to generate. So you can see here, completion, execute. Okay, I didn't say it before, but all the models, all these Jurassic 1 models, the API is called complete or completion, okay, because, right, autocompleters. So again, we're using Grande, and the prompt max tokens now is much larger because we want something bigger, and temperature that we figured out in the playbook. Okay, it looks something like this. I encourage you to read it and play with it and have fun. But now let's go through the post-credits in generator, and really more of the same, just different kind of prompt. Okay, so now we want, based on a title and a summary, to create the post-credit scenes. So again, we're creating just the prompt, then the example where it contains prompt completion, and creating the prefix, which is the pairs of input-output, the prompt and completion pairs. Now all we need to do to create the few-shot prompt is just take the prefix, add the separator, and create the prompt. This is how it will look like. Okay, generate a post-credit scene for the following Rick and Morty based on title and summary. Title, summary. You can see here, Rick needs a hug, and this is the summary that we also generated. And now, here is another call. Again, we're using Grande, and max tokens now 100, temperature 0.7, and the stop sequence is the separator. This is the 2 double hashes that we've seen. And this is the response. Okay, so this is essentially all the backend, all the NLP engine, all the smart things that happened there. Now let's just see how we build a dataset from that in case you do want to take advantage of that, and then I will summarize and get all the tips that you need to build the project. Okay, so this is how our data frame looks like. This is how the dataset that we collected looks. And now we want to build a dataset in order to train a model in AI21 Studio. So the datasets in AI21 Studio contains 2 columns, prompt and completion. Okay, just like in the few-shot prompt, but at least 50. So I'm creating this, and now I want the prompt to be create prompt for the summary, and the completion should be create just the episode summary. This is how it looks like. Okay, I have prompt and completion. I know that I have, this is how the first 5 lines look, and I'm saving this dataset. Now I want to upload the dataset into the AI21 Studio. I can do it through the API. It looks something like this: dataset upload, the path, and a dataset name. I can also do it through the studio. Okay, so the playground. So I can put here, go to datasets, continue, and you can see here RNM episodes live. This is the dataset. Let's go back to the notebook. This is the name of the dataset that I just uploaded, and you can also do like an upload and take something from your computer. Let's take a look. This is the dataset. You can see here several options in the preview. And if you want to train your own custom model, you can just click train here and provide all these details. Okay, you can also do it, by the way, through the API. So let's just take a quick look. And okay, so what we have here is the function that, given the name of the dataset, returns the ID. We're getting it, and then we are creating custom model with the dataset ID, providing model name, and choosing on which model do we want to train. We have large, grande, and jumbo. So this is how it looks like, and now we're going here to models. Okay, and you will see that this is an indication that the model is training. A small dumbbell over here, and these kind of things. How do you query a model? Okay, here you can just create for the processing dataset. It's not interesting. But how do I query this kind of model? So now I don't need a few shots anymore. All I need to do is just to create a prompt. So what will I do? I will just create this kind of prompt. Okay, so for Rick needs a hug, I want to create to use it to create. And now you see that the completion execute, I'm calling a custom model. This model, which I trained this morning in order to be prepared. Okay, and you can see that now I'm getting some sort of a summary and a result. You can really play with it and have fun, but this is what it was. Okay, and also what you can see is here when I'm in the playground, in my list of models now, I have Rick and Morty episode generator. So I can also interact with it through the playground. So let's just talk a little about things that can help you in the project and really summarize everything here and maybe give you some ideas. Okay, so large language models, they're a 10. They're awesome. They're really like the hottest thing right now. But there are several problems with all of them, Whereas the first one is that they are frozen. They don't have any new information. They only learned information on the way they train, on the time they finish training. Okay, and what we don't expect you to actually train a new model from scratch, It's something which is very, very hard, and you can't even do it in a week. But if you can find a way to connect some sort of either inject in the prompt some sort of interesting stuff, or maybe connect it to like an external API, for instance, the weather API, where you can know the weather in anywhere and connected set. Find somewhere to do it with a language model, something which is interesting and something which is quite an open problem. Okay, we call the process of doing the prompt is called prompt engineering, but as you've seen, it's a bit more of an art form, or it's a lot of trial and error. That try something to see if it works, maybe it won't work, and we don't always know why. Okay, so it's a little frustrating, but okay, you can't get out with it, and it does really amazing stuff. So it's really worth the time. And also, those models really tend to hallucinate. Right? A language model will rarely say, I don't know. Most of the time, it will just say something with actual confidence, even if it's not really connected. Okay, this is called factuality. It's a problem that every language model has. And again, this is an open problem. So if your app will touch on something like that, it will probably be like a good direction. So let's talk about tips for how to work, which will essentially be like a summary for all the presentation. So how to choose the right model, right? We've seen several models. So if you don't have any examples, if you just want to get some ideation, or if your app is all about getting some sort of a draft or something like an idea, and you don't really want to base it on something similar, something specific, you can use Jurassic 1 Instruct. Okay, the Instruct model, very capable, very nice. If you do have examples and you're asking yourself, which model should I use? My recommendation is usually go with Jurassic 1 Grande at the beginning. And really, it works really, really good. It really on the trade-off between size and performance, it really operates well, and it's much faster than Jumbo. I would start with there. If you're seeing that it's really, really easy for Grande, I would check large. If you're saying that Grande is a bit struggling and you tried all the prompts and all those kind of stuff, you can test Jumbo. Okay, and really, all of those 4 models, all of them are tagged under the complete or completion API. Okay, and your project must include at least one of them. If you want, we do have the specialized APIs in beta, like Ori said, which is the rewrite API, which is essentially the brains behind the WordTune, and Summarize API, which is the brains behind the WordTune read. You can incorporate them if you want. If you have like an idea for something which is both this and that, right? Several things, and right, you want some sort of rewrite in your project, and you don't want to work on language models in order just to do that, that's okay. You can incorporate our rewrite API, which is essentially very, very specialized in doing just that. Okay, but your project must include at least one of the complete APIs. So how to engineer a prompt good? So first of all, check several phrasing. Okay, suggest, here, write, whatever, add adjectives, play with it a little bit. I recommend to evaluate your prompts on temperature 0. Okay, even if it doesn't really, even if you want something creative and you want high temperature, if in temperature 0 you get something which is really rubbish, then probably the model it's not a good prompt. However, there is some note about that, where in temperature 0 and long text, it does tend to be a little repetitive. So if it's repetitive on temperature 0, still good, just crank up the temperature. But if it's really rubbish, you should change the prompt. If you're using few shot examples, and by the way, okay, the app that you've seen on the Rick and Morty that Yutam and myself build works on few shot. Okay, we didn't train a custom model specifically for that, just few shot on several episodes. Okay, so you can think about trying to play with the order of the examples. Sometimes it works better, sometimes not. Make sure your examples are varied. For instance, here you can see that I have 3 examples, that all of these examples have the name Morty in the title. So in this case, the model will very, very be biased to generate some sort of a title that contains the name Morty. Okay, so make sure it's varied, or for instance, if you're doing a classification task, make sure that in your prompt there is an example for every class. Okay? And use the same structure and template throughout your prompt. Okay, so for instance, here you can see in the first instruction is generate a new made-up Rick and Morty title, then suggest a new witty Rick and Morty, and then write a title. This is bad. We really want to to leverage the language model and the fact that it tends to recognize patterns. Okay, so once you figure the instruction, make sure that all of your all of the examples in the prompt is in the same structure. Or if you train the custom model, make sure that the prompt is in the same structure that you already did. I will say, okay, this is a very exciting event and it should be fun. Okay, you really should have fun with that. Language models are lots and lots and lots of fun, hours of enjoyment, and I really hope that you will enjoy here as well. And really bring your A game. We're really looking forward to see what you can build, what you can do, what will come up from here. Really, we're all here excited, and I hope that you are too. So thank you.